movie name, rating given by the customer, and timestamp not required, because when they at what time they given rating to the movie, that is not required while looking for making a algorithm for recommendation. So mainly we are looking for user ID. I'm assuming username and movie ID or movie name rating. So here rating also you can see maximum is 5 rating. So that means the rating scale is assumed to be 1 to 5. So 1 is the minimum and maximum is 5. So that is the rating scale that I'm going to assume for entire session. Maybe some ratings you can assume 1 to 10 also, that depends on the application. But in general, what I have observed, even if we take student faculty feedback also, we used to take rating scale is 1 to 5. So 5 means excellent, 4 means very good, 3 means good, 2 means above average, 1 means average or maybe poor. Like that we used to take even student feedback also for faculty. So that's why here also I'm taking rating scale is 1 to 5. But main fields or main attributes what I'm going to consider here, one is user ID, that is mandatory, and movie ID, and the resultant value is rating. So this is just like a result value or label or maybe output or supervision. So rating is 1 to 5 here. Whatever rating given by the user to the movie, that is listed here in the data set. This is a screenshot of first page of the data set. If you are looking for all the attributes, all the records, you can go through that website grouplens.org. There you can download this data set. In general, here we have to do some pre-processing before going to apply any one of the model to the recommendation. So that is called user item matrix or utility matrix, because that's why data structures is very, very important when you come to the machine learning also. So basically here, whatever data set here, we have to translate to the matrix. So that is called utility matrix, or we can call it as a user item matrix. So in user item matrix, rows are nothing but users or customers, columns are nothing but items or products or movies, depends on the application. If you are looking for movie recommendation, then columns are nothing but movie 1, movie 2, like that. So, and the values of the matrix, utility matrix, are nothing but the ratings given by the customers. Whatever ratings given by the customers, that we have to make it as a elements of the matrix in the utility matrix. As you can see here, so user 1 to item 1, we have how many users we have? If we take this synthetic data set, we have 5 users. That's why user 1, user 2, user 3, user 5, up to that. And here I can see 4 items, or maybe 4 items we have maximum. So that's why the columns are nothing but item 1 to item 4. And the elements of the matrix or entries of the matrix are nothing but rating given by the users to item. User 1 to item 1, rating is 5. And user 1 to other items, there is no rating. Understood that these are nothing but empty. Of course, we have to go for prediction. Based on that only, we will look for what items we are going to recommend to the users. And user 2 to item 1 available 4, and item 2, item 3, item 4. All the items rating given by user 2. That's why all the ratings are available. Similarly, we can go ahead with the other users. Just a second. Sir, session lo unna call chestanu sir. Sir, చెప్పండి సార్. సరే సార్, మళ్ళీ చూస్తాను సార్. సరే సార్, సరే సార్. Sorry. So just we have to make a utility matrix or user item matrix. Later we will see whatever missing values here, that is rating missing values, that we will see what we are going to do by using recommendation system. So the basic idea beyond this recommendation system here, wherever rating is missing, so the elements of the matrix missing, here elements of the matrix are missing, that we have to predict. That is the main thing. So because we have to predict the rating followed by recommendation. Suppose here ratings are missing, user 1 to item 2 rating is missing. Suppose I have to predict this rating. Later we will see how to predict by using machine learning models. We have to predict the rating. Once if the prediction is done, then we have to look for recommendation of item to user 1. So in general, I am assuming thresholding value is 4. Minimum rating should be 4 or maximum should be 5. So whenever rating is 4 or 5, then going to recommend movies or items to the customers. If the rating prediction is 1 to 3, then no need to recommend. So that means threshold value I am assuming 4 for recommendation. Suppose if you are assuming 3 also, fine. That is according to the developer, maybe depends on the requirement, but I am assuming the threshold value for recommendation is 4. So if the rating prediction is 4 or 5, then items are going to recommend to the user, otherwise not going to recommend. So that is the main thing. So that means first we should know what is the rating prediction. After that, based on the rating prediction, the recommendation system will decide whether the items are going to recommend to the users or not. But how to find rating prediction? There machine learning comes to the picture. By using that machine learning model, we can look for rating prediction for user to corresponding item or movie. So that is the objective here. You can see we have a matrix that is called a utility matrix, and wherever empty cells are there, we have to look for prediction of rating followed by recommendation. So this is called collaborative filtering model. There we can look for similarity. Based on that, we will see how we have to predict the rating followed by recommendation of the items or products to the customers. So I think you understood the objective of the collaborative filtering process. We have various measures to find the rating predictions. One is Pearson correlation coefficient, or you can go for cosine similarity, or you can go for latent factorization method. That is the concept of LU decomposition that we studied in lower classes, linear algebra. Or you can go for probabilistic classifier, that is called Bayesian classifier. Like that, we can apply various measures or classifiers for rating prediction. But I will go for simple measure that is called Pearson correlation coefficient. This is one of the simple statistical measure that we studied in lower classes in statistics. By using that, how we are going to recommend products or movies to the customer. This is a very simple formula. Even if you take cosine similarity, so that is called cosine formula that we studied in 7th class or 8th class somewhere. When you started trigonometry, at that time we studied how to find the angle between two vectors or maybe two column vectors like that. So there we used to apply cosine similar, that is called cosine formula. So that also we can apply for this recommendation system. So for finding the similarity between users in the collaborative filtering process. So anyhow, we have so many things are there, but I'll give one measure. Based on that, you can go ahead with other measures also in future if you are looking for this recommendation system application for your academic or maybe project or research point of view. So this is a base paper. So improved collaborative filtering recommendation system through similarity prediction. Because I already said our scope is nothing but collaborative filtering process. What is the meaning of collaborative filtering process? We are looking for similarity between users. Based on that, we can go for rating prediction, but still we don't know the example that I'll explain. After that, finally, whether the items or products are going to recommend or not depends on the rating. The minimum rating is 4. And maximum is 5 for recommendation. If not, the items are not going to recommend to the users. That is the assumption what we have discussed in the previous slide. So this is the base paper. There we are looking for similarity prediction. So based on the similarity, we are looking for recommendation. So for finding similarity, I already mentioned we have to go for Pearson correlation coefficient, or we can call it as a correlation coefficient formula. So this is the correlation coefficient formula. I will explain in detail in the next slide. So here, of course, notations may be different, but the formula is very simple. We have to look for numerator is nothing but covariance of two users, and denominator is standard deviation of user U, standard deviation of user V. So U is one user or customer, V is another user or customer. So because in collaborative filtering process, we have to find the similarity. Sim indicates similarity between the users U comma V. By using correlation coefficient, we can look for similarity. Based on that, we can decide the items are going to recommend or not, finally based on the rating prediction. So these things I'll explain now. This is the basic formula. So here we have xi, x bar. So let us assume what does it mean here. Xi is nothing but values of the variable x in general, like this in statistics, xy. So here x1, x2, so on, xn, and here y1, y2, so on, yn. So x bar means mean value of the variable x, y bar means mean value of the variable y, and this is called standard deviation of the variable x. This is called standard deviation of the variable y. So this is the basic idea for correlation coefficient between two variables. Same thing I'm going to apply for two users. Let us assume u1, u2. So let us assume u1, u2, user 1, user 2. In place of x, make it as u1, u2, or maybe you can see here in place of x, you can make it as ab. So A is one user, B is one user. We are looking for similarity between these two users. Whatever formula I have shown in the previous slide, that we can convert it like this. So here, let us assume A, B, and let us assume product is something. Let us assume P. P is the product I'm assuming. So this is the rating. So R AP. That means rating given to product P by A, by the user A. Next, RBP. You can see the notation. It's very simple notation. RBP means rating given by B to the product P. So this is a simple rating matrix. Of course, we have so many users also, but I'm taking two users with one product. We can make it a generalization also later. This is for specific to one product. So just for explaining this formula, RAP, this is the rating given by A to product P. Suppose if you have n products, then P1, P2 like this. RA bar means the average value of the rating A. So whatever rating A given to the product values, that we can make it as two users with one product. We can make it a generalization also later. This is for specific to one product. Next, so just for explaining this formula, RAP, this is the rating given by A to product B. Suppose if the customer B. Similarly, denominator is standard deviation of user A and standard deviation of user B. So this is a simple correlation coefficient formula that we can convert it to the similarity between two users for our convenience for recommendation system. Now I'll come to one simple. This is a synthetic data set I'm assuming. Instead of taking complete data set, what I have shown movie data set in one of the repository. So here I'm taking one simple data set that is called user item matrix is. So we have 5 items and we have 4 users, and all the ratings are available. I'm assuming whatever ratings available here, that already given to the respective products after buying. So here Dynamic to all the items are available except to item 5, and rest of the users ratings also available. Only the rating is missing for item 5 corresponding to the user or maybe customer Dynamic. Now, what is the basic idea beyond this collaborative filtering process for recommendation? First step is we have to find the rating prediction here. So we have to find the rating prediction followed by recommendation. How to recommend? If the rating prediction is 1, 2, 3, no need to recommend. If the rating prediction is 4 or 5, the recommendation system will recommend. But before that, we should know what is the rating prediction. Then we can look for recommendation of the item 5 to Dynamic or not. So that is the objective. First, we have to find the rating prediction. How to find rating prediction? Under collaborative filtering process, we have to look for similarity between Dynamic to other users. Whichever user is close to Dynamic, that rating we can take directly copy paste. So first we have to find similarity between Dynamic and Gopi, and Dynamic and Sachin, and Dynamic and Vishnu. Out of 3 users, which user is very close to Dynamic similarity, then that user rating we can consider. So that is the basic idea behind this collaborative filtering for rating prediction. So how to find the similarity? There we have to apply PCC. Of course, we have other measures also, but here we are going to apply PCC, that is called Pearson correlation coefficient. By using that, we can find rating prediction. We can find the similarity measure between Dynamic to other users. Whichever similarity is highest, that we can take it as a more similar to the Dynamic, and that rating we can go for copy paste. So here you can see I have to find the similarity between Dynamic and Gopi. So the value is, so this formula I already explained in the previous slide. So by substituting, all the values are available. You can see, so 5 is nothing but rating given by Dynamic to item 1, and 4 is nothing but average value of Daivik and first customer, and 3 is nothing but rating given by Gopi to item 1, and this is the average value of the Gopi ratings, like that. All the values we have to substitute in the formula. Finally, I got 0.85. That means 85% similarity between Daivik and Gopi. Similarly, Daivik and Sachin. So Daivik and Sachin 70%, and Daivik and Vishnu negative. That means 0. So negative means understood that there is no similarity. That means both are dissimilar. So maybe if you take two users, myself and my friend used to watch devotional movies. I am watching romantic movies. So both are contrast. That means there is no similarity. So that is the meaning here. 0 means negative value means so dissimilar. So no need to consider such type of value, and we can say directly there is no correlation between these two users, like that. So first we have to calculate the similarity between Daivik to other users. That means we have to look for highest similarity. Based on that, we can go for rating prediction. You can see here Daivik to Gopi, I have calculated 85% similarity, and Daivik and Sachin, I have calculated 70% similarity, and Daivik and Vishnu 0%. Now, when you take all the similarity measures by using PCC, which is the highest? 85% is the highest. That means the similarity between Daivik and Gopi is 85%, and others are less than 85%. Therefore, Daivik and Gopi are more similar. So both are more similar. And whatever rating given by Gopi to item 5, same thing copy paste here. Instead of question mark, make it as 3. So what is the rating prediction now? 3. Once again, so I hope you understood clearly. So here, sorry. So we have calculated Daivik Gopi similarity is 85%, and Daivik Sachin 70%, and Daivik Vishnu 0%, and the highest similarity is Daivik and Gopi, and whatever rating given by Daivik Gopi to item 5, that rating we are going to consider for Daivik to item 5. So finally rating prediction done. Now, after rating prediction, whether item 5 is going to recommend to Daivik? No, because I already mentioned the threshold value is 4. That means minimum rating should be 4. If the rating is 4 or more than 4, then we can consider. If the rating is less than 4, that no need to go for recommendation. Suppose if you fix 3 is the threshold value, at that time item 5 is going to recommend to Daivik. But as per my initialization or maybe threshold value, minimum rating should be 4, then only we can recommend items to the customers, otherwise not going to recommend. So finally item 5 is going to not going to recommend to Daivik because rating is 3. So therefore you can see the final conclusion, item 5 is not going to recommend to Daivik. Suppose instead of 3, suppose if the rating prediction is here, instead of 3, rating prediction is 4 or 5, then item 5 is going to recommend to Daivik. Or maybe if you fix threshold value is 2, then in that case also item 5 is going to recommend to Daivik. But in our case, so the minimum threshold value is 4, so that's why item 5 is not going to recommend to Daivik. So this is the way the recommendation system will work for collaborative filtering process by looking for comparison of the users. Based on that it will recommend. So that's why most of the time when you look for a comparison with other users, so maybe comedy movies means maybe same comedy movies I am also watching, then whatever movies watched by that user, it will recommend to you, like that. So that is the basic idea behind this collaborative filtering and how to apply to the given data set with simple measure that is called PCC. Of course, base paper also I have shown that is published in IEEE. Maybe this we have a quiz, but if you want you can do, otherwise leave it. So just you can see here, just I will show the quiz, maybe interested can answer it, otherwise I will show the answer. So we have a movie data set. We have 5 movies, movie 1, movie 2, movie 3, movie 4, and we have 4 users, and these ratings are missing. Movie 1 rating is missing, movie 3 rating is missing, movie 4 rating missing by Vishnu. So these are the 3 ratings missing. Now we have to decide which movies are going to recommend to Vishnu. So that is the objective. So that means we are whether movie 1, movie 3 or movie 5. Out of these 3, which movie 4, out of these which movies we are going to recommend. So for that same concept we are going to apply. So here I'll give the answer, correlation coefficient value, but you can decide which movies are going to recommend. So you can see here right side, the similarity between Vishnu and Daivik is 32%, and the similarity between Vishnu and Ramesh is 73%, and the similarity between Vishnu and Somu is 21%. I think you can understand the similarity. So 32%, 73%, 21%. Now tell me, so what is the rating prediction followed by which movies are going to recommend to Vishnu? I hope you understood the problem statement. So we have movie 1, movie 3, movie 4 rating prediction. That means the ratings are missing and we have to find the rating prediction, movie 1, movie 3, movie 4. After rating prediction, which movies are going to recommend to Vishnu. So anyhow, I given the similarity measure also. So Vishnu to Davik 32% similarity, Vishnu to Ramesh 73% similarity, Vishnu to Somu is 21% similarity. So out of these, so identify the best similarity and followed by rating prediction, followed by which movies are going to recommend to Vishnu. So just analyze and post your answer in the chat box. And anyhow, I'll give answer also. I'll provide the answer also. I hope you understood the problem statement and most of the solutions I given already. Just we have to look for highest similarity, followed by rating prediction, followed by which movies are going to recommend to the user or customer Vishnu. Just you can post your answer in the chat box. I will check it. If not, also I will give the answer for this problem. It's a very simple quiz. Anyone can answer easily. So more than 50% of the solution I already provided here, the evaluation of PCC, because it will take time to evaluate. That's why I given right side. So 32%, 73, 0.21 means 21% like that. So let me check the chat box if any answers or any responses from the participants. If not, I'll provide the answer also. There is no issue. It's very simple, basic idea only. Yeah, good. Prabhaharan, Neelu, Kaushik, Pinde. Yeah, fine. Thank you for response. At least you responded, and the answers also correct. Yes, few more queries. Nityasri sir, please provide some of the sessions for paper or books. Yeah, I will provide. Don't worry, Nityasri. At end of the session, I have one more slide that is called resources. Maybe I will provide some of the textbooks. You can go ahead with that, and we can get the insights of the models or maybe intuition of the models of machine learning. That I will show, no problem. Yeah, fine. So thank you for the response. And now I will move to the conclusion or maybe a final answer for the quiz. Not conclusion of the session, just for this quiz. Still, we have so many things are there. Yeah. So here, what it indicates, so we have calculated the correlation coefficient. So I have only calculated. Now 73% highest similarity between Vishnu and Ramesh. So you can observe that 73% is the highest similarity between Vishnu and Ramesh. Whatever rating given by Ramesh to movie 1, copy paste here. Whatever rating given by Ramesh to movie 3, copy paste here. Whatever rating given by Ramesh to movie 4, copy paste here. Hope you understood the rating prediction. Now we have to look for which movies are going to recommend to Vishnu. I already said minimum should be 4 rating. That is the threshold value what we have fixed for recommendation. Of course, you can fix 3 also. That is it depends on your company requirement. Maybe it depends on the developer. But here, as per the scope of the session, I have fixed 4. So that means. Please, participants are requested to mute so that no disturbance for others. Yeah, fine. Thank you. So movie 1 is going to recommend 100%. There is no issue because rating prediction is 5. So it's no doubt at all. And movie 3 is not going to recommend because rating is 1. It's a worst rating or poor rating. And movie 4 also going to recommend. So therefore, finally, movie 1 and movie 4 are going to recommend to Vishnu. Whether Vishnu is going to watch or not, that is left to Vishnu. So there is none of the business of recommendation system. The recommendation system objective is to find the rating prediction followed by recommendation. Finally, movie 1 and movie 4 are going to recommend to Vishnu. So this is the final conclusion. So you can see here, movie 1 and movie 4 are recommended to Vishnu. So this is, of course, the answers posted by the participants are correct. So thank you for the response. So this is the way movies or products are recommending based on the collaborative filtering process. I'm not talking about any content based here. Content based purely based on the past activity. So here I'm talking about only collaborative filtering process. There I'm looking for similarity between users, hence followed by rating prediction. Finally, the recommendation system will recommend movies or maybe products to the customers. Now I'll show healthcare application also, how the recommendation system will work for healthcare with one simple case study. What I have explained, similar case study I'm going to consider. So this is published in Journal of Intelligent Information Systems in Springer. So recommendation system in healthcare domain. So we have so many recommendation scenarios in healthcare domain, like food recommendation. So based on the disease, what type of food you have to take, that type of recommendation. And drug recommendation, based on the disease, what type of drugs. Drugs means here tablets. Suppose if I have fever, so $6.15 you have to take. This type of recommendations you will get. And physical activity, based on the disease or maybe based on your health condition, what type of physical activity you have to do. Suppose you are sick, maybe you are suffering with fever, so the recommendation system won't recommend you how to do 1 hour gym like that. So depends on your healthcare situation, it will recommend what type of physical activity you have to do, maybe running or exercise, etc. And healthcare professional recommendations, so depends on the health situation or maybe disease, so it will recommend healthcare professionals. Maybe if you are struggling with some kind of fever or maybe cancer, etc. So based on that disease, the specialist, maybe one doctor is specialized in the cancer diagnosis, maybe we'll get that type of recommendation of the doctors. So that is the meaning of healthcare professionals recommendation. So here I will show how to go for drugs recommendation. Drug recommendation means prescription recommendation. So this is the data set I found in the previous paper published, that is called healthcare recommendation system in healthcare domain. So as you can see here in this data set, we have attributes age or maybe columns, age, insulin level, glucose level, BMI, that is called body mass index, BP, blood pressure, and thickness. Thickness means fat level. So that these are the medical terminologies. Even I don't know initially when I gone through this one. After that, I typed in Google what is this TRIPSI thickness something. After that, I found thickness is related to fat level. And we have, this is the historical data. We have 4 patients. You can see here. This is called historical data, fast data. We have patient 1, patient 2, patient 3, patient 4, and corresponding attribute values also available: age, insulin level, glucose, BMI, BP, etc. And Tom is the active patient. So is the active patient. What does it mean? So he visited the doctor, maybe he visited the product, whatever it may be, product, data product we have. So he is having the data product and he is the active patient, and his data is not available. Now he is trying to get the recommendation of the prescription. For that one, we can call it as active patient. So he is the active patient, and historical data, we have 4 patients data. Now, basically, what our objective is to, which prescription we have to recommend to Tom. Already we have 4 prescriptions: patient 1, patient 2, patient 3, patient 4. Now I have collected, let us assume I have a product, a data product. So in that data product, I have collected age, insulin level, glucose level, etc. from the active patient. Now, which prescription we have to recommend to Tom? Prescription means there we can find what type of tablets you have to take based on the symptoms, etc. Maybe when you visit a doctor also, after telling your symptoms, I have motions, I have headache, or maybe stomach pain, etc., you will give some prescription. After that, you can bring to the pharmacy, then you will take the medicines. So similarly here also, so he has to enter all the attribute values, then you will get recommendation what type of prescription he has to use, like that. Here also we are applying similar logic what we have applied for movie or product recommendation. So first we have to look for, so here basically we are looking for similarity between Tom, comma, PI. So let us assume PI means I value varies from 1 to 4. 1, 2, 3, 4. So P1 means patient 1. We have to look for similarity between Tom and patient 1. Then I equal to 2. We have to look for similarity between Tom and patient 2, 3, 4, like that. Out of all the similarities, we have to look for highest similarity. Based on that, whatever prescription is available for that corresponding patient, we can recommend to Tom. That is the basic idea beyond this, like how we recommended the movies or products in the previous case studies. So how to find similarity means, similarly we can apply cosine similarity, or we can apply PCC similarity measure. Just now we discussed. First we have to look for similarity between Tom and patient 1. What is the value? 86. We know how to calculate by using correlation coefficient. And after that we have to look for similarity between Tom and patient 2. So Tom and patient 2 is 51%. Next we have to look for similarity between Tom and patient 3, that is called 49%. And finally similarity between Tom and patient 4, 4%. Now, as you can see here, what is the highest similarity? 86%. So rest of the values are less than 86%. That means there is a huge similarity between Tom and patient 1. So Tom also age 25 and patient 1 also is similar. Insulin level also close, both are similar. Glucose level we have a little bit variation, and BMI body mass index also similar, and BP level also almost close, and the fat level also almost close. Because of that reason only we got similarity between Tom and patient 1 is 86%. Now what is the conclusion? Whatever patient 1 having prescription, same thing will recommend to Tom. That is the final conclusion. You can see here the calculation shows that patient 1 is the most similar to Tom. Hence, the drugs prescribed for this patient can be recommended to Tom. Whatever drugs prescribed for patient 1, because already available in the data set, that is the past data set or historical data. So whatever prescription is available for patient 1, same thing we can recommend to Tom also. So you can save money, no need to go for consulting doctor, a lot of manpower or energy, all those things we can save here. So that's why recommendation is very, very powerful even for healthcare or pharmaceutical industry also. You can see this is the final one. So this is a patient 1 prescription. So you can see RX 650 mg tabs, something we don't know about medical terminologies, all those things. But this is a prescription of patient 1. Same thing is recommended to Tom also. You can see name of the patient name is Tom. Here patient name is patient 1. Let us search. Same thing will recommend to Tom also. So this is the way the prescription or maybe drugs are recommending to the patients based on the historical data. Even if you take healthcare specialist also, suppose what is your main symptom, you can select cough, maybe headache, fever, etc. Then automatically you'll get recommendation of the doctor near to you. Suppose I am staying in Whitefield, Bangalore. If I enter symptoms, I won't get recommendation of the doctor from Hyderabad or maybe Secunderabad, etc. So I will get doctor recommendation near to my area, maybe with limited maximum. It will try for maybe within less distance. Still not available, maybe little bit next distance. So it won't look for too much distance. Also, we have this type of apps also. So automatically we'll get recommendation of the doctor. This we can call it as a professionals recommendations to the patients based on their symptoms. So this is also one of the application for healthcare industry. So even we can apply collaborative filtering process by using Nave-based classifier. Of course, we can apply Nave-based classifier for rating prediction also. Here the basic idea, I will give the basic idea. Sorry. Yeah. So here I'll give basic idea. Just a second. I'll make let me make one empty slide so that I can explain easily. So when you come to the Bayesian classifier for this recommendation, what we have to do, we have rating prediction 1 to 5. So we have to take P of y equal to 1, rating 1, given x. X is nothing but the ratings given by the customer to other items previously. We have to find the probability by using Bayesian classifier. Let us assume 0.4. After that, we have to find rating 1, y equal to, because the response or class is nothing but 1 to 5 categorical values. So because I'm taking rating is 1 to 5 range, that's why we have to find all the ratings probability given x. So x is fixed here. So 0.1, let us assume probability, and probability of y equal to 3 given x. X means the ratings of the same customer given to other items or other products. So this is 0. Let us assume 6. So probability of y equal to 4 rating given x, that is called future vector. So 0.76, and probability of y equal to 5 rating given x, the probability of y rating is, let us assume 0.1. Let us assume some value. So we have to find like this. If you are looking for Bayesian classifier or any other classifier for rating prediction, we have to find rating all the ratings probability, because I'm looking for probabilistic classifier. So out of this, we have to look for maximum probability. So maximum, what is the maximum probability here? 0.676 is the maximum probability. So maximum probability is 0.676. Now which corresponding to which class? 4. Therefore, the rating prediction is 4. So that means previously we used to calculate this rating prediction based on PCC method. Just we have to look for similarity, and based on the similarity we have to identify the rating. But here we have to apply classifier, probabilistic classifier, in which we have to calculate the rating, all the ratings probability, out of which we have to look for maximum probability. That maximum probability corresponding to which class? 4. Therefore, the rating prediction is 4. That means we can call it as a Nave-based classifier as org max P of y given x. So the output is nothing but, let us assume y cap. So max is nothing but 0.76. Argmax is nothing but the maximum value corresponding to the rating. Rating is 4. Therefore, the rating prediction is nothing but 4. So this is the way we can calculate. I'm not explaining in detail by taking complete intuition, because just for explaining this probabilistic classifier for recommendation system will take minimum 45 minutes. I have to explain intuition. After that, I have to take data set. That much time we don't have. But I'm giving the I'm showing the path. If you are looking for this probabilistic classifier of that section, you can go through this one. So just you can derive the classifier. Anyhow, I'll show that also later. And after that, we can find the rating prediction for all the possibilities. Then we can look for maximum value, that maximum value corresponding to which label. This is basically categorical classification. So because we have binary classification means true or false, but here rating prediction means it comes under categorical classification, because 1 to 5 rating. So out of that, maximum probability corresponding to which rating, that we can consider as a final rating prediction. Maybe if we take 1 to 10, we have to find all the 10 probabilities. Like that, we can go ahead for the probabilistic classifier for finding the rating prediction for movies or products or maybe other applications. So that is the base paper here. That is also published in IEEE only. So IEEE means standard publications only. So a collaborative filtering, because we have done a collaborative filtering approach by using similarity. That is called Pearson correlation coefficient. But here, how to apply Naive-based classifier. So that is the idea what I have given just now. So evaluation, I will skip because we don't have time. Just let me skip this one. So evaluation is mandatory. Here basically we are looking for actual rating, predicted rating, find the RMSE value. Less RMSE value will give the more accurate model. That is the meaning here. So otherwise, let me cover this also just a second. It will take less time only. So here, whenever if I go for any machine learning model, obviously we have to go for evaluation. Without evaluation, we can't decide this X model or Y model is the best for the given data set. So that's why we can't say this model is best for movie data set or this model is best for product recommendation, like that. So depends on the data set. So we have to apply model, and out of that, which model will give the more accurate result, that we have to deploy to the application. That's why no one will say this regression, Bayesian classifier or maybe decision tree or random forest or KNN or maybe some support vector mission, this is the best for this data set, like that. We can't find anywhere in the conclusion. So it may vary. Today I'm applying SVM for 100 records. Maybe tomorrow if I apply 200 records, at that time maybe the accuracy may change. Because of that reason, so we can't decide this is the best model. Because of that reason only, we have to apply maximum number of models to the given data set. After that, we have to go for evaluation. Evaluation is very, very important in machine learning. So pre-processing is very important. Training model is very important. After that, evaluation is very important. Once if you done these steps in the processing of the machine learning for any application, finally we can deploy to the application. So now when you are looking for evaluation, we have to look for RMSE for this recommendation. So root mean square error. So first here we have to look for RA is nothing but predicted rating, actual rating. PI is nothing but predicted rating. Make some whole square divided by n. N indicates number of records, and find the RMSE value. So why we have to make square? Sometimes we'll get negative value. When you make some, it becomes 0. It does not mean RMSE is 0. Because of that reason, when you make a square, negative square also will get positive. Positive square means positive. There is no issue. Because of that reason, always we have to make a square. So that's why we can call it as a root mean squared error. Square is very, very important here. So always less RMSE value indicates always best model when compared to the other model. That's why RMSE value should be always less. As you can see here, I'm taking one movie data set. Movie 8, these are the ratings, actual ratings in the test phase. And these are the rating prediction by the model, any model. And we have to find a difference square, so that we'll get 5.6 is summation PI minus RI square. PI is the prediction rating, RI is the actual rating. RMSE value is nothing but 0. Here n equal to 10, number of records 10, that's 4. So 5.6 divided by 10 square root, so that the value is 0.57. This is the RMSE value. Suppose if you have a movie data set and I have applied various models, which model is the best for the given movie data set? Let us assume when you apply PCC, Pearson correlation coefficient, I got RMSE is 0.57. When you apply probabilistic model, what I have explained briefly, not completely, briefly I have explained. So 0.31, that means 31% RMSE value. and cosine similarity 0.45 I got, and matrix factorization 0.43. Like that, by applying various models or measures, I got RMSE value 0.57, 0.3, like that. Now, which is the best model for the movie data set for recommendation so that we can deploy to the application? Probabilistic model. Why probabilistic model is the best? RMSE value is very less when compared to the other models. That's why we can say probabilistic model is the best for movie recommendation. Hence, we can deploy to the application. The deployment process is over. Hence, we can stop the application. So that's why always evaluation is the final one. Then we can go for deployment process phase. So because of less RMSE value, we can say this is the best model. So that's why always evaluation is very, very important. And machine learning for healthcare, especially for classification or diagnosis. So this is also very important. Here I'm going to apply Naive-based classifier. So just I'll skip this one. Here a lot of mathematics is there. So just because we don't have time, just I'll skip this one. Yeah. So here I'll give the idea. So we are looking for supervised learning model. Supervised learning model means it's a labeled data. So we have a class that means input data as well as output data, that is called supervised learning model. So mathematically I'll give what is the meaning. Whenever if I take supervised learning model, it's a very simple function that is called input values. Let us assume X, or maybe let us assume F is nothing but input cross output, which makes a model. Let us assume M1 something. This is called supervised learning model. This is called labeled data. We have input as well as output, which will maps to the model. Next, if you take unsupervised learning model, this O is missing. There is no output. This is unlabeled data. Based on the similarity or maybe based on some clustering, we can make a model M2. So when you are looking for semi-supervised, it's a combination of labeled as well as unlabeled data. So this is a simple mathematical functions how to represent supervised learning model, unsupervised learning model. So if you want more clarity, if you have X, X1, X2, and Y. So these are nothing but input values. This is nothing but output. We can call it as a label, or we can call it as a class, or we can call it as a supervision. Some values are available, then we can call it as a supervised. Y is available. Suppose if Y is not available, we can call it as a unsupervised. Suppose Y is available for some X1, X2 and some X1, X2 not available, we can call it as a semi-supervised. So here this we are taking into consideration of supervised learning model. We have each record output. So for R1 we have output, for R2 we have output, like that. It's a binary classification basically. Now how we are going to apply classifier per class? Suppose if we have a new test instance, let us assume RM plus 1. So last one more record I'm adding, and X1, X2, the future values are future vector values are available. We have to go for classification. I have to classify whether the data belongs to C1 or C2, whether the person having cancer or not. So for that, our aim is to apply the classifier that is called Bayesian classifier. How we are going to apply? Here basically what we are going to do is, so we have to apply two classes we have. So Y equal to C1 given X, this we have to calculate. X is nothing but future vector, whatever futures we have given, that we can consider, and what is the probability of this one. For that, what we have to do is we have to find argmax, maximum value, or max value P of C1 into P of X given C1. So this value, of course, I'm not giving in detailed explanation because it will take a lot of time to explain this. Lot of mathematical models also I have skipped in the previous slide because of time factor. So just we have to find the argmax. What is the difference between max and argmax? Max is nothing but maximum value. Argmax means maximum value corresponding to the variable value. Suppose here, let us assume what are the classes we have here. So argmax, let us assume C1, C2 like this. So let us assume CA, CA. So C1, C2 like this, CA. So here let us assume C1, C2. So maximum value is, let us assume C1, and that corresponding to argmax means, so we can take it as a finally output is nothing but C1 like this. This is the final classifier. So finally, what's the conclusion here? When you are looking for predictor, Y cap equal to, so argmax probability of Y given X. Still, if you want more clarity, so this can be written as argmax. What is the P of Y given X explanation in the Bayesian classifier? So probability of y into probability of x given y. So here y values are C1, C2. So either class C1 or class C2. So we have to find the probability, both probabilities. Let us assume argmax. For C1 probability, I got 0.6, and for C2 probability, I got 0.2. C1, C2. Here, these are the classes what I have considered for the given data. Out of this, what is the maximum probability? Let me use some different color. 0.6 is the maximum probability. So max is 0.6, but we are talking about argmax, the maximum value corresponding to which class? That is the meaning C1. Therefore, the final classification y cap equal to C1. So this is the Bayesian classifier in summary. So because I'm not explaining in depth Bayesian classifier because it will take a lot of time. So this is a summary of Bayesian classifier. We have to find each class probability. Out of that, we have to look for maximum probability. That maximum probability corresponding to which label, that is called argmax. So for example, if we take Ramesh got 98%. And Geeta got 99%. Suppose if someone will ask what is the highest marks, highest percentage, immediately we will say 99. Suppose if someone will ask what is the argmax, then argmax is Geeta. Try to understand difference between max and argmax. Max is nothing but maximum value of the class. Argmax is nothing but maximum value of the percentage corresponding to which student. That means name of the student is nothing but argmax. Here also we are looking for which class C1, because the maximum 0.6 is corresponding to the class C1. That's why y cap is nothing but C1. So this is the difference between max and argmax. Now here I'm going to give, sorry, these things, these explanations, leave it. Just I'm skipping this because it will take time to explain all those things. Yeah. So when you come to the classification process, we have a new data. I have to collect the symptoms of the patients. After that, we have to apply Bayesian classifier, what I have displayed briefly. And finally, we have to go for classification of the class, either C1 or C2, or maybe if we have categorical classification, C1 to Cn. So now this is a simple process in healthcare. We have to collect symptoms from the patients based on the new symptoms. So we have to classify. So let us assume I'm taking simple COVID-19 synthetic data set. Already we have a past data that is called historical data. We have 9 patients data and all the symptoms are available, like pain, healthy head. And the class also available, whether the patient having negative, positive COVID, or negative COVID, like that. So this is the synthetic data set. Now this is the active patient, new patient data. Chest pain, dry cough, etc. One patient visited the doctor, is having chest pain, dry cough, etc. Now, based on these symptoms, I have to classify whether the person having COVID-19 or not. So for that, what we have to do, this is called future vector X, and what is the class? C1, C2. So we have to find P of C given X. So for each class, we have to find the probability, and we have to look for maximum probability corresponding to that. We can say the positive or negative COVID for the given patient. So these are the symptoms I have collected, that we can call it as a future vector. 5 futures I have: fever, chest pain, and class either positive or negative. That's why what we have to do, probability of C1 given X. This probability we have to calculate by using Bayesian classifier. What is the formula here? So probability of X into probability of, we have to calculate probability of class 1 given future vector X. For that, we have to calculate probability of C1 into probability of X given C1. This probability we have to find. Let us assume 0.6. I'm not explaining in detail how to calculate, just I'm writing 0.6. Next, probability of C2 given X. This probability also similarly, probability of C2, class C2. This data we have already available, how to calculate probability of class 1, all those things in the previous. For example, if you take here in the previous data set, probability of C1, that means COVID positive, 1, 2, 3, 4, 5. Out of 9 cases, 5 cases COVID positive. That's why probability of C1 is 5 by 9. That's the meaning. So that is the meaning here. Directly I written some random number here. Probability of X given C2. This value is, let us assume, 0.3. Out of this, which is the maximum probability? So 0.6 is the maximum probability, and this maximum probability corresponding to which label, which class? C1. Therefore, finally the conclusion is the patient having COVID positive. So this is the actual process. By using that, we can classify the given data is C1 or C2, because we are looking for COVID positive or negative. So even if we take a flu disease, also same process, we can take the futures or symptoms, based on that we can calculate. Even for email filtering process also. So for example, we have a mail. By using machine learning model, let us assume based in classifier, what we have done, we have to calculate the probabilities. So if the probability is highest for spam, then we can classify the mail is spam. If the probability is more for not spam, then we can classify it as not spam. Like that, we can go for classification for email spam filter. So the data set looks like this. So here we can find ham, spam. You can see here one example for spam. So yeah, so here you can see these are the keywords, urgent, and you have won this type of keywords, free membership and price, jackpot, this type of keywords, client, this type of keywords you can find in the spam mails. Based on these keywords only, we can classify whether the mail is spam or ham. That means not spam. If you are looking for complete data set, you can go through these repositories, either Kaggle, or maybe you can go for UCA machine learning repository. You can find n number of data sets, so which may useful for your research point of view, or maybe project, or maybe implementation of any algorithm. So for example, this is the data set I have. We have 5 mails, and here you can see free, weather. These are the keywords. Email 1, free keyword repeated 5 times, frequency, and lottery 7 frequency. So this type of mails are spam. Not spam means we can find free, lottery, this type of keywords are not available. That's why not spam. So like that, we have 5 mails. I have a new mail in which free keyword frequency 7 times, and the lottery frequency is 6 times, and promotion 8 times. Now we have to classify whether the mail is spam or not spam. So obviously the mail is spam, because why means we have a free and promotion, all those keywords are available. Based on the historical data, this mail goes to spam. So finally, how we got spam? The probability of spam is more than probability of not spam, that is ham. That's why finally we have classified the new mail is a spam mail. So like that, we can go for a classification of the mails based on the data, whatever data we have received. So mainly here we have to apply any classifier. Here I applied probabilistic classifier. We have to find the probability for spam as well as not spam. But in our case, spam probability is more than not spam probability. Hence, we can classify the given data is a spam. That means spam mail. So this is a simple way we can classify the mails. This is also very one of the important application for this machine learning. So finally, we have classified the mail is a spam. So this is a predictive algorithms. So here in predictive algorithm, basic idea is, so we have a historical data, we have to apply predictive algorithms. By using that, we can make a model, and whenever new data we have received, we have to go for prediction. Like I gave already example, weather prediction, or maybe rainfall prediction, or maybe number of COVID cases prediction, or maybe country GDP prediction, or maybe number of students are going to pass prediction. This type of applications, or maybe house sales prediction, this type of applications we can do by using predictive analytics, so which is also a subset of machine learning. So basically what we have to do, we have to take historical data. Here linear regression is very important. I think yesterday's session Shishkala madam covered this concept. So by using linear regression model, so this is the model. Let us assume y equal to f of x comma c. This is a linear regression model. Now new data is, let us assume, so 2, 3, I have to find the y value. Then what we have to do, y equal to f of 2, 3, then this value is, let us assume 10. So that is the final prediction. So that is called predictive analytics. Based on the historical data, we can find the future value. So we have various types of regressions, linear, polynomial, all those things. Just I'll skip this one. Yeah. So here in coronavirus data use case, I will consider. So if you are looking for coronavirus number of cases each day, you can go through this website, Our World in Data. In this website, you can find a lot of information about number of COVID cases, number of COVID deaths, all those so far, even across the world. Maybe you can find a state-wise also, or you can find country-wise also, or you can find a number of COVID cases per million also you can find. So I will show screenshot. This is a screenshot. There we can find so many call attributes, and number of COVID cases, number of COVID deaths, and number of hospitals. Like that's a lot of information is there. You can go through that Our World in Data. You can find complete information. So by using predictive modeling, we can find number of confirmed cases in Nigeria like this. This is the one paper published in elsewhere. Here basically applied the linear regression, y equal to a plus bx. So mx plus c. B is nothing but slope, a is nothing but y-intercept. So we have to make a model. Let us assume like this. This is the regression model I'm assuming. So 2x plus 3, let 2 plus 3x, let us assume. And whenever if we have new data, let us assume 10, the value of number of COVID cases corresponding to this X. Let us assume here 50, we can find. So this is a basic idea beyond this linear regression. Of course, this is also a vast topic, but I given just, so we have to find the linear regression, and after that substitute X value, we can find number of COVID cases corresponding to the X value. That means day. You can see in this paper also apply linear regression, y equal to a plus bx. And after maybe for some data, they applied multiple regression, because when you have more number of independent variables, we have to apply multiple linear regression. Based on that, we can find number of COVID cases. The cyber security, I think, just a second, I will skip this one. Okay, the cyber security application I'll do. After that, we'll wind up. So nowadays we have a huge number of threats are happening through network, or maybe through some systems, or maybe through some other resources. How to protect the data? So here basic idea is, I'll give very simple one. Suppose we have a college, this is a college, and here we have a security room. So every college, obviously we have security here. So why we require security? So the security will protect our assets, whatever assets we have, maybe whatever it may be, classrooms, or maybe desks, or maybe fans, or maybe buses, or whatever it may be, all the assets we will protect. So that's why we are keeping security day and night time. Similarly, when we have an organization, this is organization, we have data, we have systems, we have network, we have something else, servers, etc. So maybe there is a possibility to attack this by third person. So is the third person is trying to attack our data. There is a possibility is there. To minimize this one, or to avoid this one, we require cyber security mechanism. So that's why cyber is nothing but computer system, program, network, data, etc. Security means, so we have a security mechanism. It may be a system security or network security, etc. By using the cyber security mechanism, we'll try to avoid this type of threats, or we can try to avoid this type of attacking our data or maybe computer system. So that's why cyber security plays a vital role nowadays. So there is a brief concept of cyber security. So cyber security is nothing but set of technologies which will help to minimize attack our assets. Assets means here computers, programs, computer, maybe data, or maybe network, etc. So that's why here the definition is very simple. Set of body of technologies or processes, practices to protect networks, computer, program, etc. Now you will get doubt. We are talking about machine learning, all those things. Why this cyber security comes to the picture? Yeah, I'll come to that one. So here he is the third person is trying to attack our data. Here we have assets, whatever it may be. So here assets means like a program, network, computer, etc. How to he is trying to attack, but we are minimizing. So how to do this one? By using machine learning. So their intrusion detection system plays a vital role. So even when you see one of the recent poll, so 50% of the participants are opted machine learning and AI will drastically change the security model in next 5 years. Even as per the Capgemini report, so by 2025, more than 80% of the companies are going to use cyber security to minimize the attacks or to minimize the threats. So that's why cyber security, not only machine learning, even for when you apply machine learning to other applications as well as cyber security, so we are going to get huge opportunities or huge jobs are going to create. So because of that reason, so cyber machine learning also plays a vital role for cyber security application. So I'm going to explain a very simple one. So this is the data set, and we have to do, this is unknown file, this is unknown data we have received through network, and we have to classify the data is benign or malicious. So benign means good, malicious means bad. So whether the data is good or bad. Bad means immediately it will give alert, that we can call it as an intrusion detection system. So here we have to go for intrusion detection system. Intrusion detection system is nothing but a security mechanism. It will monitor, it will alert to the administrator whenever there is a bad data received or is there any threat received by the through network. So such type of applications we have to go for machine learning. So basically the machine learning will identify the data, and whenever the data is little bit bad, immediately it will give alert to the administrator and he will go for further step. So that's why here you can see the definition. Intrusion detection system will monitor, detect and respond to the unauthorized activity inside the company, then immediately will give the alert. So for that, how machine learning comes to the picture. So we have a data set like this. This is called KDD Cup 99 data set. You can check it from UGC machine learning repository, and label is nothing but output. You can see the last column output. We have data like this. So whenever if new data received, we have to classify whether the data is normal or abnormal. For that, machine learning comes to the picture. By using that, we can go for classification. Here I am taking simple data, and this is the new data, and I applied Bayesian classifier. When I apply Bayesian classifier for normal data, I got this probability. For abnormal data, or we can call it as Neptune type of attack, that is called web servers related attack. So I got this probability, and obviously abnormal data probability is more. Hence, we classified the given data. What we have received in the network is nothing but bad data, or we can call it as a abnormal or malicious data. So this is a way we can do classification by using classifiers. Here I applied Bayesian classifier. Maybe you can apply KNN, support vector mission, or Bayesian tree, or maybe random forest, depends on the application we can apply. Maybe this I'm skipping. Even captures identification also we can apply machine learning, because this is one of the security mechanism. There we can apply neural networks for identifying the capture, because every day when you are going for bank account or maybe something, so you will get captures. So their machine learning plays a vital role for recognition of the captures. Finally, it will allow. There, of course, here this also I will skip. This is Bitcoin analysis. So Bitcoin analysis also we can do by using a regression model. We have to find the closing price of the Bitcoin by using a regression model. So linear regression or multiple regression. But here we have number of independent variables are more than one. That's why we can go for multiple regression model. Even traffic prediction, this is the data set for traffic prediction. So day and date. So we have to find the traffic. Here, this is a categorical classification. Traffic is 5 means heavy traffic, maybe more than 50 cars, or maybe traffic 1 means there is no much traffic. Like that, we can go for categorical classification for this traffic prediction. You can see the description. So whenever the classification is 1 for traffic prediction, less than 5 cars. 2 means 5 to 15 cars. 5 means that is the highest value, more than that means heavy traffic. So such type of applications we can go for regression model. By using that, we can go for traffic prediction. So if you are looking for further enhancement of the concepts what I have explained, because it is difficult to complete all the concepts with complete intuition, all those things within just a span of 1.5 hours. So that's why I'm showing some of the resources. If you are looking for further enhancement of the subject, you can go ahead with these materials. So we can go through this one, machine learning and deep learning in real-time applications. Maybe I will share these two organizers also, Dilip Kumar sir, maybe sir will also share to you so that you can go ahead with that. And we can find complete applications, all those things. And recommendation system, if you are looking for recommendation system with implementation, you can go through this hands-on recommendation systems with Python. This is one of the latest cutting-edge technology, and a lot of research is going on this concept because of huge number of applications of recommendation system. And this is open source textbook, you can download it also. And mathematics for machine learning. So without mathematics, studying machine learning, deep learning, artificial intelligence, data science, natural language, but there is no use. So try to understand, without mathematics, these subjects, if you study also, there is no use. So try to learn mathematics basics. No need to go for exceptional or maybe high-fi mathematics. So I have explained simple mathematics only, probability, like that for a classifier also. So we should know mathematics properly. Maybe you can take data and you can apply to the formula. That's not a problem. Anyone can do. But you should know intuition of that mathematical models. That's why you can go through this textbook. Even you can download this textbook through Google, and you can find the complete mathematics for machine learning. And especially when you go for deep learning, you'll get a lot of mathematics. It is very difficult to understand. Such a huge mathematics is available in the deep learning. That's why try to take the first basics of mathematics, then you can go for further mathematical concepts, depends on the application. So this is one of the top recommended textbook for mathematics for machine learning. And online resources, you can go through this mltute.com. You can find a lot of material about machine learning with the textbooks and PDFs and data sets, all those things. For data sets, you can go through this UCI machine learning repository. You can download benchmark data sets, and it will minimize your pre-processing, especially like EDA concepts, all those things we can minimize here. This is one of the, of course, you can go for Kaggle, GitHub, other public repositories also, but here you can find a huge number of data sets, depends on your application. Here, such option is that you can type that search whatever data set you required, it will display automatically. So that was my brief concepts on application case studies. If you have any doubt, I'm happy to answer, or you can post your query in the chat box. I will read and answer it. Hope you understood. I'm showing the just path because of this time limit. I have shown the path. Now, based on that, you can take into consideration and you can use any of the resources, and you can further enhance the machine learning for various applications and case studies and implementation by using Python, etc. Because so many things are there, that's why not able to cover all those things. Let me check the chat box. If you have any queries, you can post your query in the chat box.
అంటే ఫోటోస్ కాకపోయినా నాకు వేరేదన్నా మ్యాటర్ అన్నదని ఉండాలి కదా, ఎవరు హెచ్ఓడి అని తెలియాలి, ఆయన తీసేయని చెప్పారు, ఇంకా ఇమీడియట్ గా తీసేసి.
So if you have any queries, please unmute and ask me, or you can post your query in the chat box.
Participants, please respond. Sir, in chat box, one of the similarity calculation, one more time they asked. No problem. Already, that is
already done.
Yes, done. And what is the probabilistic model? I don't know what they tell the answer, sir. Probabilistic model.
No. I asked some question at that time. They answered.
Okay. I think participants, any queries? Yeah, they, sir, kindly say the presentation, sir, if possible. They asked. Sir, one more question. When a cell is empty, how to calculate the similarity?
No, actually, when the cell is empty, that's why we are doing similarity with other users. Suppose one cell is empty, we can take that user to other user, then try to come to the similarity. First fill that cell, then again you can go to the actual user. Then we can find. So once again, I'll explain Neelu Kaushik. So first, when you are looking for some X person to Y person similarity, if Y person also having empty cell, then what we'll do, Y person you can try to compare with other users. Then you can find at least one user with non-empty cells. That rating you can consider. Then you can go back to X and Y comparison for similarity. Then you can find the rating. Yeah, thank you. Welcome.
Sir, once again, I thanks to Professor Somsekhar sir as so many delivered 145 technical tasks within a span of 1 year. I appreciate, sir. AICT, all are in funding projects only. AICT, FDPs, IEST, FDPs, STTPs, UGC, FDPs. Thank you, sir, for valuable time, your time, and also you were given the free talk. It is an honor to me to given the free talk. On behalf of Similarity Engineering College, we are pleased to highly appreciate your presentation and deliberation as the resource person for the FDP on machine learning, big data analytics principles, techniques, and challenges, organizing the Department of CSC. We would like to convey our sincere thanks and gratitude for your fruitful session on the conceptual understanding the big data, machine learning, and deep learning. Your presentation is enriched the participants of the FDP with the knowledge and created an intellectual environment. And also we will feel honored to collaborate with you in future also, sir. Thank you very much, sir.
Welcome, sir. Thank you all participants for your response. So very nice response for all the queries what I have asked. So thank you, sir, for opportunity once again. So we will look for more sessions in future also.
Yeah, thank you, sir. Thank you very much, sir.
Thank you, sir. Thank you. Bye.
Participants, any queries is there? Can you